Hi, I'm Jack Westwood, a software engineer at Couchbase. In this demo, I'll show you how cbsh Shell makes it easier to experiment with Couchbase's new vector search features.
One of the use cases for cbsh Shell is that it can lower the cost of experimentation with new features. So in this demo, I'll show how cbsh Shell makes it easier to experiment with Couchbase's new vector search features. So imagine you already have a dataset that contains some vectors. For the purposes of this demo, we'll be using the travel sample dataset that we've enriched with vectors using some other cbsh Shell commands. For an example on how to enrich your own data with vectors using cbsh Shell, check the similarity search recipe in the Couchbase Shell docs recipe section. So let's take a look at one of these documents with the vectors in. So we can do that using the .get command and by giving the key of the document we want to get. So this is what the return from a .get command looks like. You can see we have the ID column that contains the key of the document, and then we have the content column which contains the body of the document. So this is just one of the landmark type documents from the travel sample dataset, but it has one additional field that we've added, and that is the content vector field. So this content vector contains a vector representation of the content field. So this content field is just a textual description of the landmark and what you can do there. And what we've done is using cbsh Shell, we sent that off to a LLM and got this embedding, which is a representation of this text. So now that we also enriched all of the landmark documents with similar vectors. So that means that we can use them as a base to create a vector index. So we can create vector indexes using the vector create index command. The first argument to this is the name of the index that you want to create. So in our case, it's going to be landmark content index. The name of the field containing the vectors that you're creating the index over. So as you've seen, that's content vector for us. And finally, the dimension of the vectors in those fields. So the dimension of a vector is just its length, so the number of floating point numbers that comprise it. So in our case, you can see the final index of our vector is 1535, and since the index starts at 0, the dimension of it is 1536. So now that we've created now our vector index is being created, the last thing we need before we can perform a vector search is some input vector. So for example, one way we can get an input vector is from the document that we got originally. So since we don't want the whole contents of the document and we just want what's contained in the content vector field, this is a good chance to use our sub.get command. So the sub.get command takes the name of the field that you want to get, as well as the key of the document that you want to get that field from. So if we scroll up and take a look, you can see that the output of a sub.get is quite similar to a .get. We have an ID column that holds the key of the document, a content column, but this time instead of holding the contents of the whole document, it's just the content of the field that we specified when we run the command. And finally, you've got some metadata, so the cache, cluster, and errors if there are any. So before we can use this for a vector search, we need to get at this vector within the content column. So fortunately, that is quite easy to do. We just run our sub.get command, and then we can select the content from the content column. So now that we have our vector, we're ready to do our vector search. So to do that, we just need to get our vector again and pipe that directly into our vector search command. So the vector search command needs you to give the name of the index that you want to use for your vector search. So in our case, that's one we just created, landmark content index, the field over which the index was created, so that's the content vector. And finally, we're going to specify the number of neighbors that we want returned using the neighbors flag. So what a vector search does, it does a k nearest neighbors search. So what that's doing is it's taking this vector that we've given as a point in n-dimensional space. So in our case, it's 1536 dimensions, and it finds the n or the k nearest neighbors. So in our case, the 5 nearest neighbors. So here you can see it's returned the 5 documents in our index that have the most similar content vector to the one we've supplied. So here's the similarity score, and here are the IDs of the results. So the top result is landmark 1009, and that's got a score of infinity because the vector in there is the same. It's the document that we got our vector from. And then, as you can see, these all are in decreasing order. So once we have that, we can have a look at how similar the content field of these are, since that's what we use to create these vectors. So what we can do is we can pipe the output of our vector search command into a sub.get, and we're just interested in the content field in this case. So if you take a look here, here's the content of the original landmark 10019. So you can see it's describing a museum on military engineering and history. So some of the other results, we can have a look to see how semantically similar they are. So here you can see this is another museum. So that's somewhat similar. Retirement home for soldiers. And some more museums. So you can see we've already done a kind of semantically similar search just in a few commands. So another valuable source of vectors that cbshell can help you to generate is just from plain text, and we can do this using the vector enriched text command. So what this will do is it takes a text string that you give it. For example, let's say physical activities. And what it will do is it will generate an embedding for you that represents the text that you've given it. So it does this by sending it off to a configured LLM. And if you want to have a look at how to connect an LLM to cbshell, just please check documentation. So if we run that command, we can see that it's generated a vector for us that represents our text. So again, now that we have that vector, we can pipe it into our vector search command. Again, we want to do landmark content index over the content vector field. Let's do 5 neighbors again, and then let's have a look at the content. Okay, so we've got landmark 562 includes swimming pools, sports halls and gyms, swimming squash racket. So as you can see, all of these give us landmarks that are related to physical activities. We as humans would understand these as related, but you can see that none of the fields actually contain the words physical activities. So it's already kind of highlighting the value that similarity search can bring to your data. Hopefully you can see how Couchbase Shell makes it easier to experiment with Couchbase's new features. And if you want any more details, please check out the recipe section of our documentation for some in-depth walkthroughs of forming similarity search and enriching your existing data with vectors ready to experiment with similarity search.
Thank you for watching. For more information, head over to couchbase.sh to check the documentation.